Oh!
Well played.
GG! GG!
Disgraceful. When you drink it, you spit in it, and then you give it back to him.
Oh, sorry.
Yeah. Alright, kinetic and potential energy.
Do we do it at the same time? Do we do it at the same time? Like,
We'll do both in this lesson. Yeah.
I'm good at that.
Okay.
Yeah, ready.
oh!
See?
Yeah.
You know, like, bomb transform.
You are much better than him.
Yeah, of course.
Of course, obviously. This is the thanks you get for helping her by giving her some coke. Is this your breakfast, by the way?
Yeah.
Yes, okay. Alright, continue?
Yeah.
Right. Okay, so if an object is moving, then it has kinetic energy. And this energy is from some work being done on the object. So that is, the kinetic energy is the work done to give it that energy. So what I mean is, if this is at rest,
Right.
not moving, and then it is moving with speed v and its mass m, then something must have done work to it. Yes?
Yeah.
They pushed it.
Yeah.
So this now has energy. It got its energy from the person doing work. So in other words, the work done equals the kinetic energy. Let's work that out. So what we have here, let me just see. What we have here, first it was at rest. Then the V is V. The A we don't know, the T we don't know, and the S we don't know.
Yeah.
So this is the problem. So we have kinetic energy equals work. But what's work equal to? Force multiplied distance. Okay, well we don't know the force or the distance. But what's the formula for force?
MA.
MA. And distance is S. Okay, so this isn't looking good either. But we need to remember that we can use a formula here. We can say V squared equals U squared plus 2AS. So you have V squared equals 2AS. So what I'll do is I'll put a half in the front and a 2 in the back. So it's still the same. But what have I made here? 2AS. And what's 2AS? V squared. So this is a half V squared. So we've just proved our first formula. The first formula is that the kinetic energy is a half mv squared. So this is our first formula. We'll have two formulas today. Okay, so write this down. Can you see okay? Yeah.
What if it was moving?
Yeah, when we talk about kinetic energy, we say the energy it got from going from rest to its current speed.
Okay.
Yeah, this is the definition of kinetic energy. It's always compared to as if it was at rest. Okay, do you have this written down? Yeah? Okay, so that's our first one, kinetic energy. So let's see. So you can probably guess what the second formula is we'll have to do. Potential energy. So if we think about it, this ball is on the ground, and now it's up at a height h. It has energy because it can do work. Because you could drop the ball and break someone's head open. So you can do work here.
Nice one.
Nice work done, yes, indeed. So where did the ball get its energy from here?
Sun.
Not that far back. Someone, not necessarily threw it, but just somebody lifted it up to this height. Yeah, just raised it up to that height. Yeah. So, the energy here, again, is equal to the work done, which is the force by the distance. Now, in this case, we actually know the distance is h. But for this person to lift it up, what must the force equal? Yeah, it must equal at least mg, so mg basically. So that's mgh.
Yes.
And now we have our second formula, potential energy is mgh. Yes. Oh, so simple. I make it look so simple. Yeah. Yes? Continue? Okay. So, again, same thing here. The force brought it to that height. That's where we got this formula from. Okay. So we've done that already. Some things to say about potential energy though. So potential energy can be positive, zero or negative. And I'll draw the three different situations. If it's positive, yeah, very good. So if it's positive, it has potential energy, and like you said, it's in the air. But what about if it's zero? On ground level. So we call this state free. So we say it's free on the ground. But what does negative mean? Underground, yes, true. And what word would describe this? We say it's trapped. Now, more technically, we say it's trapped in a potential well. So before you write it down, I just want to draw the three situations.
Wow.
Yeah. So here, potential energy is positive. Here, it's zero. It's a person. And we say it's free.
Yeah.
And then here, this we say is trapped. And the potential energy is negative. So negative means it's trapped. Zero means it's free to move. Positive means it has energy stored in it. So these are the three different states. It's actually important to remember this one because people forget that negative means trapped. So negative does have a meaning here. So, okay, you can draw the picture and make note here, please. And this is important vocabulary. Potential well. Trapped in a potential well.
What about positive?
Positive just means it has energy. There's nothing unusual there.
What did you say about potential well?
Yeah, the vocabulary is, we say it's trapped in a potential well.
So the meaning of
Potential well means negative potential. It's trapped.
it doesn't have potential energy.
No, it has negative potential energy. Yeah. Okay. You have this written down? Nearly? Potential well is important vocabulary, KJ, because it's what is used in physics to mean negative potential energy. Has anybody seen that vocabulary before? Potential well? No? It's a new vocabulary? Okay.
Is it just negative potential?
Just negative potential energy, that's all.
I mean,
The-
in people usually would say negative potential energy.
No, in physics it'd be more usual to say potential well. Okay, continue. So we had a look at an example, I drew it there, my picture. So the conservation of energy means that the kinetic and the potential at the start has to equal the kinetic plus the potential at the end. So as a formula you could actually write it like this. That the energy at the start equals the energy at the end, meaning the kinetic plus the potential at the start equals the kinetic plus the potential at the end. So this is conservation of energy as a formula. Okay, so please note this. Whoops. This. Okay. Got that formula? Yeah? Okay. Bruce? Not yet? Okay. You've probably seen this before. Okay. Bruce, okay? Yeah. Right. Let's have a look at an example. We'll do this together. As 1 kilogram ball is dropped from rest from a height of 10 meters, how much potential energy does it have at the start? So what's the answer for that? MGH. So you have 1 kg and it's dropped 10 meters. So part A is what's the potential energy of the top. So as you said, that's MGH, which would be 1 times 9.81 times 10, which is 98.1 joules. How much kinetic energy does it have at the beginning? It's not moving at the beginning, so it has 0. Yep. Okay, C. How much potential energy does it have at the impact, at the end? Down here. Potential energy. Down here. 0. And finally, how much kinetic energy does it have down here at impact? What is it?
98.1.
Very good, 98.1 joules, because the kinetic energy here should equal the potential energy here. Let's check that, let's confirm that. So, using our formula, we can check it's the same. A half mv squared. Do we know m? We do, it's 1, so that's 0.5. Now, do we know v squared? No. But we can say v squared equals u squared plus 2a s. So that would be 98.1 joules as well. So it works. Yeah, 2 times 9 point... Oh yeah, and then there's a 0.5 in the front then. So, it cancels then. Okay, so that's our first example. A basic example. If you can write this down, we'll look at a more difficult example next. Did you write this down, Bruce?
No.
Top, top, bottom, bottom. Oops. Okay. Put this down, Jerry? Yeah.
I don't want to write it down.
You don't want to write it down, why not?
Because I won't read it again.
Will you really?
Yeah, because
You will watch my video again?
No, I mean I want to read it again.
That's terrible.
No, I mean I just review some.
I'm shocked, my heart. I can't take this.
We'll play.
I really don't really.
You really don't want
I
to?
review some.
Yes.
I just do some important one, like E equal half. I do require.
Okay. Okay.
Okay.
Next. Okay. Write this down. I'll do this one. You can write or draw this. Yeah.
This is projectile.
Now you see, this is interesting because it is projectiles, but we can answer this without doing it the way we did it in projectiles. Yeah?
Yep.
Continue. Okay, so here's the bullet, and it's fired from a height of 10 meters at a speed of 100 meters per second. So if this was a projectiles question, first you would have to get the T, then once you have the T, you would have to get the Vx, the Vy, and then the V here.
Yeah.
But we don't have to do that now, because what we can say is that the energy here equals the energy here.
Yes.
What type of energy does it have here?
What can you do?
And kinetic.
Yeah.
So the mass is 0.1. mgh Was it 0.1? No,
No,
0.2. Plus a half v squared.
Yes.
And what energy does it have here?
Yes.
Only
Oh.
kinetic.
Yes. V. Yeah.
Yeah. Okay. That times that is 19.62 plus, this is 1000, and then 0. Is it 1,000? Yeah. 0.1 v squared. So that's 1019.62 over 0.1 is v squared, which is 1019.6.2. So v is the square root of 10,000. What's that? About 100? 113?
97.
100 and...
97.
I can't hear both a few times. We'll give Jerry a chance here. Go ahead, Jerry. 100.97. Yeah?
Yeah.
You sure?
98.
I just thought it would be more than 100. Because... It is this? Okay. So that's 101 meters per second. Which, when you think about it, is not that much faster. Because it was going 100 at the beginning. So it's only increased its speed by 1 meter per second and fallen. Why so small? Probably because the time it spent falling was so short. I expect t here to be rather small. Meaning it doesn't have much chance to gain Vy.
It's not that something is not
No. No. The answer is the same. Because look, yeah, here you can actually do this. So in fact the m is not important. I didn't need to tell you the m. It was not necessary. Okay, can you write this example down? Yeah? Yeah, so you can see that it's useful, a useful formula to have.
And can you use it in toilet?
Yes, you can. Yeah. Yes, yeah. Useful, yeah. If the question was a projectile question that simply said, how fast is it going when it strikes the ground? You can do it this way for sure. Now, if it said, how long until it strikes the ground? This formula is no good because it has no time in it. Yeah. Okay. People are writing? Bruce, you got it?
yeah.
Are you sure? Brian? Yeah, okay. So, let's see. I think I'll do another example. How hard do I want to make it? Okay. Yes. Does anyone know what this triangle is called in physics when you put something on it? Yes? Go on, you're going to say it. Yes, a wedge. This is called a wedge.
Wedge potato.
Same word, different meaning. And this one?
Block.
A block. Okay, and we'll make this 30 degrees, and we'll make this side here 10 meters. Oh, that's too big.
10 centimeters.
That's too small. 2 meters will do nicely. Okay, and my question is I want to know how fast it's going when it gets to the bottom here. So I want to know its speed. Now I'll do this one in a minute, but I'd like you to try it. I've actually given you enough information to do this. Try. And of course it starts from rest here. Yeah, you don't know it.
What is that?
I'm not telling you.
Very good.
Yeah, just the speed. Oops. How are we doing here? Got any answers? Seems very big. 90? 19. That's better. Not 90. Okay. So, Sean, what to do first? First, yes.
Find the height.
Oh, you're not Sean. You wish you were Sean. You're not Sean. What to do first, Sean?
I know the G equals 9.8.
Yes? Ah, no.
What?
Not this. Very interesting. Not this.
Is it 6.6?
I don't know what it is. Haven't worked it out. But what I should do first is calculate this side. 2 cos 30, and this side is 2 sine 30.
1. Yeah, 1.
This is 1.
Yeah.
Good. So, the potential energy here equals the kinetic energy here.
Yeah.
So, M G H, which is 1, not 2, yeah, equals a half V squared. Cancel, cancel. So V is root 19.
Oh.
You forgot the roots.
Yes,
Yes, you did.
4.4.
Shouldn't we think about the speed of?
No, because the great thing is that this V is the V speed when the Vx and the Vy are combined. This is the wonderful thing about this formula, that this is the speed with both components in it. So you might be thinking this V is only for one of the components. It's not. It's actually for both, which is what makes this formula so useful. Yes, do we have this? Now let me just, before you write it down, let me just add that to my list of questions here. Oops. One sec. Okay. A block is placed on a wedge inclined at, what did I say, 30 degrees. What is this? It's just me adding this question to my notes. To the ground. The longest face of the wedge is 2 meters long. The block is placed on the top of a wedge. How fast is the block going when it reaches the bottom of the wedge? Beautiful.
So have you ever learned computer science?
I know many things. I did a little computer science.
You don't know computer science?
I know a little computer science.
Like, do you know like Java language?
Java?
Java.
I know Java.
Java. C language?
Yes, I know C, C++.
It is difficult to learn.
Yeah.
Difficult than.
I don't like this one.
I don't like changing.
Well.
What else do I know?
And something.
You learned that before.
M something?
High school classmates went out me to
MATLAB.
Oh, I don't know MATLAB. I know Mathematica. Not MATLAB. What else do I know?
Do you know everything? Just
Not everything.
0 and 1 is which language?
I tried everything.
I don't know this one.
Just use 0.
Just using 0 and 1.
Which language? I forget.
Computer 1, 0, 0.
I don't know what to call that. Binary, yeah, but I don't know if that's what he means. Binary is 0, 1. Yeah. Yeah. This is my. I like this one a lot.
Yeah. Which one?
Python.
Python.
Yeah. This Java I don't really like so much.
So hard.
It's hard, yeah.
Hard, yeah.
Yeah, it's difficult. This one's okay. This one's okay. This one's okay. These are okay. This one is hard. This one's easy.
Java and electrical, like electricity, which is more hard to.
Java and electricity.
Different.
Yeah,
Is it different?
you can't really compare.
Yeah. Depending.
The computer is a.
And the computer science.
I was thinking a book about Java language. Right? Oh,
Let me ask you this. Do you know any of these languages?
I don't know.
Then you will find Java hard.
I don't want to learn computer like I have to write something
Yes.
to make a program.
Yes.
I don't like that. I want to learn electricity, but my high school students learn.
The high school, if you go into electrical engineering field, you have to learn that too.
Really?
Yeah.
Maybe just not as much.
Not everyone has the computer science.
Yeah.
Information technology.
Because
Yeah.
the programming
Information
language,
technology,
and
you
then
must
they all were
learn
Java.
Java.
Yeah, I think so.
And Java, that's a mandatory.
Yes, it's basic. Yeah.
And the Java is
Yeah.
Sorry, I studying computer science.
Jesus, I don't want to study computer.
teacher,
I want to learn electricity.
teacher,
Yes.
for what you are doing now is which one?
Which one?
Physics and math. One.
This language?
I love chemistry.
Oh, that's neither of these.
Oh.
That's this one. LaTeX.
What is that?
I know. I also know LaTeX, HTML, and a little bit of CSS.
It's IT.
I know sex.
Good.
I know sex.
Cultural
I know
trend.
sex online. I
I don't know what are you talking about.
Yeah.
You know what online?
What? CS.
See?
I want CSS.
It's a game.
Crossfire.
Shooting game.
Shooting game?
Yeah.
Not interested. Not interested.
Oh, yeah.
Okay, I forgot to print this lesson, so I have to put the questions up on the screen. but I'll print them out later for maths class. You can have a start on them now for a few minutes. Kinetic and potential energy questions here. So if you can try these for a few minutes. Can you see them okay? Do you want to take a picture and then I can...
Jerry will get a paper later.
We will get paper.
No, wait. Do you want me to take one picture and then I can scroll down and take these? Okay. You got this? Okay, now wait.
No, wait. Oh.
Okay. You got both?
Then I'm to be.
Then
Okay, what picture about Euro?
they know.
Say again?
Yeah.
Try.
We will have paper.
Yeah.
Alright.
I'll print it later. I didn't print it. I printed the wrong page.
Okay. 100.
Can you see? Yeah.
Teacher.
You know what a teacher is, don't you?
What is it?
The teacher is Jerry. My high school student.
Jerry is not 100 kg.
My high school partner.
100.